Hello viewers, you are welcome to my channel. On today's topic, we'll be looking at oxidation number. If before now having challenges on how to calculate oxidation number, you don't need to worry, because at the end of this lesson, it will be as simple as ABCD. Alright, let's look at the meaning of oxidation number. What is oxidation number? Oxidation number can be defined as a charge on the ion, So what do you mean as charge on the ion? Any ion that carries charge. The oxidation number is that charge. For example, look at this chloride ion. What is the oxidation number of this chloride ion? It simply means what? -1. Calcium ion, the charge, oxidation number is the charge. That is what? +2. Okay, look at sodium. This sodium atom, it has what? 1 electron on its atomic shell. So sodium can go into chemical bonding by donating this electron or losing this electron. Before that, this sodium atom, neutral sodium atom, the oxidation number is what? 0. But it might not be written 0 like this. Oxidation number is 0. So look at this one. When it loses 1 electron, it becomes what? Sodium ion. That's Na+. So the oxidation number of sodium ion is what? +1. Because it loses what? 1 electron. Okay. It is the number 2. Another definition of oxidation number. It is the number of electrons required by an atom to attain a filled electronic structure. So as you can see, at the end, when sodium loses an electron, it has attained what? A filled electronic structure, octet configuration. Atomic electron being 8. Okay, let's look at the rules that will guide us in calculating what? Oxidation number. Rule number 1. Okay, let's look at rule number 1. The oxidation number of an ion is the charge on it. Look at this. That's the example I gave before. This is chloride ion. This charge is what? Its oxidation number -1. If I have this, it's just +1. Remember, plus is what? +1. So the charge. So that's what rule number 1 says. The oxidation number of an ion is the charge on it. Okay, let's 2. Rule number 2, the sum of oxidation number. The sum of oxidation number of all atoms in a compound is equal to 0. So what do they mean? Look at this. This is sodium hydroxide. The charge on this is what? Is plus. This one is minus. If I sum this thing, +1 plus -1. That is 1 minus 1 is equal to what? 0. So the sum of oxidation number of all the atoms in a compound is equal to 0. Look at this one. Calcium, this calcium oxide. What is the oxidation number of calcium? You know, calcium has what? 2 valence electrons in its atomic shell. So that's what? The oxidation number of calcium is what? +2. Because it's going to lose that electron during chemical bonding. So +2. What of oxygen? Oxygen has 6 electrons at its atomic shell. So it needs 2. It will accept 2 electrons to acquire what? A filled electronic structure. So the oxidation number of oxygen is what? -2. So the sum 2 minus 2 is what? 0. Let's look at rule number 3. The oxidation number of any element in its free state is equal to 0. So what do you mean by free state? When the element is alone, it's not combining with another element. That's free state, a non-combined state. Look at this oxygen. That's not combined state. Oxidation number was 0. Look at calcium. Uncombined state is 0. If I have something like this, This oxygen is has combined with what? This is oxygen in a combined state. So the ratio number of oxygen here will be what? Will be -2. But here is equals to what? 0. So remember, if you are given a chemical equation, for example, calcium reacting with what? Oxygen to give you calcium oxide. To give a calcium oxide. And you ask, what is the ratio number of oxygen at the beginning of the reaction and the end of the reaction? Here is alone is 0. Here is what? In the combined state is what? -2. Okay, let's look at rule number 4. The oxidation number of hydrogen is +1, except in metallic hydride. So what do we mean metallic hydride? Metallic hydride, when hydrogen is directly combined with a metal. This is sodium metal. This is what? Of course, sodium is a metal. This is the oxidation number of the what? Plus. So remember, sodium has 1 valence electron. So the oxidation number of sodium is +1. Hydrogen, in this case, hydrogen have a what? -1. So only metallic hydride, the oxidation number of hydrogen will be what? -1. The oxidation number of hydrogen is +1, except in metallic hydride, which means if it's not a metallic hydride, the oxidation number of oxygen there is what? +1. Look at this. In water, the oxidation number of hydrogen here is what? +1. In ammonia, the oxidation number of hydrogen here is what? +1, and so on and so forth. Let's look at rule number 4. Okay, let's look at rule number 5. The oxidation number of oxygen is -2, except in peroxide. In peroxide, its oxidation number is -1. So this is oxide ion. This is a peroxide ion. So if you calculate the oxidation number of oxygen in a compound and you're getting -1, it shows that that compound is what? A peroxide. Okay, so look at this. This is a peroxide. This peroxide, when you check the oxidation number of oxygen, it will give you -1. If you check the oxidation number of oxygen in water, it will give you what? -2. So the oxidation number of oxygen is always -2, except in peroxide. So let's look at the 6th rule. The oxidation number of elements in group 1. All the elements in group 1. Remember, periodic table. Elements in the periodic table are arranged. Elements are arranged in groups according to what? The total number of electrons in the atmos share. For example, group 1, they have 1 electron in their atmos share. So that's 1 is what they're going to use to go into chemical bonding. So the oxidation number, because they're going to donate electron and give out electron, the oxidation number is what? +1. Those in group 2, +2. Elements in group 3, the valence electron is +3. The elements in group 4, they can use 2. They have 4 electrons in atmos share. So they can either use the 2 to go into chemical bonding, or the entire 4 to go into chemical bonding. So when they do that, the oxidation number will be either +2 or +4. Element in group 5, remember, in the definition said the number of electrons required by an atom to acquire a filled electronic structure. So those in group 5, they have 5, so they need 3. They need three more electrons to acquire what? A stable electronic configuration. So because I'm going to accept 3, the electronic configuration is what? -3. Those in group 6 will be -2 because they need 2. Those in group 7. So you can use this to also remember it. I did a video on how to calculate formulae from valency, how to write chemical formula from valencies. You can watch it, very, very interesting. I give a detailed explanation of oxidation number and the valency. Okay, let's continue. Also remember, aside from this, some elements, some metals have variable oxidation number. Even some elements in this group 5, group 6, elements like sulfur, phosphorus, nitrogen, Even chlorine also have what? More than one oxidation number. So most of those elements that have more than one oxidation number, they often ask students to do what? To calculate it. So calculate oxidation number. Some metals like zinc, okay, the charge on zinc is what? 2 plus. So oxidation number of zinc is what? Plus 2. Some metals have more than one oxidation number. You can see copper. This copper 1 and this one is what? Copper 2. Solve some calculations. Calculate the oxidation number of the underlined element or the underlined element. Of the underlying elements. Okay. Remember, if you are asked to find the oxidation number, the name will not be given to you, because if I call this thing, for example, I'm asking you to find the oxidation number of iron, and I say write the oxidation number of iron 3 oxide. You already know iron 3. The 3 there is the oxidation number of iron, and of course the metal, so it will have a plus. So nobody will give you the name, because if you call the name already, the oxidation number is there already. So you just be given like this and say find oxidation number of this. All right, let's start with number 1. Okay, the formula for calculating oxidation number is what? Sum of oxidation number is equals to what? The charge. Remember, if the compound, if the molecule or the compound is neutral, the charge will be 0. For example, look at this. There's no charge here, not put any charge here. So the total sum of oxidation number of this of the atoms in this compound will be equal to what? 0. If it has a charge, look at this one that has charge. It will be equal to what? The charge. So I'm looking for, remember, we are calculating for F2O3. So how many atoms of iron do I have here? I have 2 atoms of iron. So 2 times oxidation number of iron. I'm looking for it. You can say, let the oxidation number of iron, let it be what? X. So I normally use the metal to represent, apart from oxygen. It's only oxygen I prefer to put what? I like to use the X, but you can use S to represent your atom. You're good to go. So let it be what? I'm looking for this one. I don't know it, but I have 2 atoms plus I have 3 atoms of oxygen. 3 times the oxidation number of oxygen, and I said it's always minus 2, except in peroxide. This is not a peroxide, so put your minus 2 equals to the charge. What's the charge? 0. So 2 times this will give us what? 2Fe. 3 times minus 2 is what? Minus 6. Three times minus 2 is minus 6. Minus 6 times plus will give me what? Minus 6. And equals to what? 0. Fe is equals to what? If I cross this minus 6, if you cross the quantity side, it becomes what? Plus 6. Six divided by 2. So to now give me what? 3. Remember, it's positive for 3. So you put plus. This sign is very, very important. Very important. If you calculate this without putting sign, just put 3. You say 3 is 3. No, it's not like that. Because talking about the oxidation number is charge. So that's very important. If this happens to be what? Assuming 2 mass for the answer, only the answer carries 2 mass. I did not put this charge. You are likely to lose a half mark. That's 1 mark out of it. It's very important. Please always remember to do what? To put the sign. If it's negative, put it. If it's positive, put it. Always remember to put the what? The sign. Very important. Okay, let's look at number 2. So number 2, we are looking for this. We are looking for the oxidation number of chromium in Cr2O7 2 minus. How many atoms of chromium do I have? I have 2. So 2 times the association number of chromium. Remember, we're looking for it. Plus, how many atoms of oxygen do I have here? 7. 7 times the association number of oxygen, which is -2. So -2. What is the charge? The charge is what? -2 is the charge of the radical you're asked to calculate. So put -2 there. So 2 times Cr, 2 Cr, 7 times -2 is -14. -14 times plus. That's what? -14 is equals to -2. 2 Cr. This is -2. So this -4, 14. Crossing the quantity sign becomes what? +14. 2 Cr is equals to -2 plus 14 will give me what? Give us what? +12. If you want to put +12, it's okay. But if you can still remember your sign, very important, so always remember your sign. So Cr, how do you get? If I divide everything by 2, I will get 6. So it's like 12 divided by 2, which should give me what? 6. This is a positive what? Number. So add your sign +6. So it means the association number of chromium here is what? +6. We are looking for the association number of copper here. Yes. How many? No. We are looking for the association number of nitrogen. Nitrogen in this. Association number of nitrogen in this. Look at this. What is the association number of copper here? Remember, I told you have copper 1, copper 2 ion. Look at this. If you know how to write chemical formula, you're able to know that this copper is copper, this is copper 2. The association number of this copper is 2. Look at this. For you to form chemical formula, remember, the atoms are radical. That's always what? They always interchange their valencies to form a chemical formula. This is what? Triosonitrate 5 ion, nitrate ion. It has a charge of minus, NO3 minus. So that minus is the valency, put it. That's the radical. Sorry, that's the valency, put it there. You interchange. When you interchange, it will not be like this. So this shows that the association number of copper is +2. So I did a video on how to write chemical formula. Very interesting. Go through it. You're going to learn a lot. All right, let's look at it. So the association number of copper here is what? +2. Remember, we won't be given the list of association number in exam. We won't be given the list of association number where you pick it up. I say copper is like this. You pick it up. No. So this copper is 2. How many atoms of copper do I have? I have 1. If you still want to say yes, I have 1. What's the number of copper? +2. Plus, remember, what is inside this parenthesis? These 2 affects only what is here, not the one that's outside. So 2 times, how many atoms of nitrogen do I have here? I have 1. 2 times 1. That is 2. So I'm looking for the association number of nitrogen. I call it N. Plus, how many atoms of oxygen do I have? 2 times 3. That is what? 6. 6 times the association number of what? Oxygen, which is always what? -2. Put it -2. This compound, is it charged? It's not charged. So some of the association number will be equal to what? 0. You put your 0. So 1 times +2. 2 plus 2n plus 6 times -2 will give us what? -12 equals to 0. So 2n. If I move the numbers to the other side, you can either move it to the other side or you also do 2 minus 12 and continue. You see the same thing. Anyhow, in any way you want to put it, you're still correct. So this -12 crossing the other side will be +12. This 12, positive 12, crossing the other side will become what? -2. So 2n will now be 12 minus 2 is what? 10. My n will now be what? 10 divided by 2, which is what? 5. And the 5 is what? Positive. You add your sign. Please always remember to put this sign. Very, very important. So that you get a full mark. So let's look at number 5. That number 5 has to do with what? Water of salt that has what? Water of crystallization. Don't be scared when you see such if you have to find a oxidation number of any of the elements there. Okay, form. So I want to state something. We have to find the oxidation number of sulfur here. So remember, some oxidation number of all the atoms in the compound is equal to 0. So this one is a compound on its own. Water is a compound on its own. This dot, it means they are going to add plus. But this thing, this water, some oxidation number of hydrogen and oxygen will give you what? 0. This one is another compound on its own, which means you can say some oxidation number of water is equal to what? 0. Is equal to what? 0. So what it means that when I come here, I'll put plus 0. You are still correct. If you still want to put, I'll solve the 2 method. I'll use the 2 method to solve. So look at this sodium. I have 2 atoms of sodium. What is the oxidation number of sodium? Is what? Remember, sodium in group 1. So it's plus 1. Plus S. I'm looking for S, and I have 1 atom of S. Remember, if I have 2, I'll just say 2 times S. So I have 1. What is the oxidation number of oxygen? I have 4 atoms of oxygen here. 4 times the oxidation number of oxygen, which is minus 2, plus 0. What is the charge of the compound? So what is the charge of the compound? It's no charge, so it's equal to 0. 2 plus x plus 12 plus 4 times minus 2 will give me what? Minus 8. This is S, not 5 from sulfur. Alright. Plus 0 is equal to what? 0. 2 minus 8 will give us what? Minus 6. Minus 6 plus 0 will give us minus 6. So S minus 6 is equal to 0. S minus 6 move to the right side because what? Plus 6. So I've seen this method. I also use the one, if I did not call this one, let this, if I not say let the sum be 0. I think I asked to find the oxidation number of oxygen, sorry, hydrogen in this compound. So remember, this one is a compound on its own. I can say let's the oxidation number of what? The sum of oxidation number of Na2SO4 is equal to 0. Yes, you are very correct. So it's now be 0 plus 10 times 2, 20 H hydrogen plus, you see, get and let's say give it the same way. Okay, let's do the other method pattern. Let's do the other one. I have 2 atoms of oxygen, 2 times plus 1. I have 2 atoms of oxygen. I have 2 atoms of sodium. Oxidation number is plus 1. Plus S. Plus 4 times minus 2. Plus 10 times 2 is what? 20. So 20. What's the oxidation of hydrogen? So always plus 1. 10 atoms of oxygen here. Plus 10 times, what's the number of oxygen? Always what? Minus 2 equals to what? 0. Equate it to 0. So 2 plus S. Remember, plus 4 times minus 2 is what? Minus 8. 20 times 1 is what? 20. 10 times minus 2 is what? Minus 20 is equals to 0. So here having, look at this. 20 minus 20 is what? 0. So 2 minus 8 is what? Minus 6. So S minus 6 is equal to 0. What is my S? S is what? Plus 6. So you can see, either way you use, you are good to go. So if you have to use the other method, please always state that sum of association number of molecule of water of 10 moles of water is equals to what? 0. Whatever the number that's been given to you. So just say sum of association number of H2O is equals to 0. Just state it before you start solving. Last one. And to find the association number of nitrogen in what? N2H4. I have 2 atoms of nitrogen. And I don't know the association number of nitrogen. I call it what? N. I have 4 atoms of oxygen. 4 times, what association number of oxygen is always what? Plus 1, except the metallic hydride. Nitrogen is not a metal. This is not a metallic hydride. So it's plus 1. What is the charge on this atom? There's no charge, so it's equals to 0. 2n plus 4 times plus 1 is what? Plus 4. It's equals to 0. So 2n, this plus 4 crossing the positive side becomes what? Minus 4. So n will now be what? Minus 4 divided by 2. What is our n? Our n is minus 2. Minus 2. So you can see that nitrogen here has what? The association of nitrogen here is what? Minus 2. So nitrogen has variable association states. Yes, minus 2. It can also be minus 3. It can also be plus 5, plus 4, plus 2. Alright. We've come to the end of the lesson. Here is a practice question. Calculate the association number of the underlying elements, ion and what? Oxygen. When you do it, post in the comment section. We have come to the end of this topic on how to calculate association number. I hope you can calculate, you can find association number of an element in a compound or ion without any difficulty. Alright, when you do it, post it on the comment section. If you're not subscribed to my channel, please kindly subscribe and like. Bye. Have a great day. Bye.